All right, so let's take a look at this activator. Here we had to solve this inequality. You might recall that an inequality or solving an inequality is very similar to solving an equation. There is one thing that needs to happen when we solve an inequality, and I'm going to address that now. So our first step is to get rid of this constant, which is the minus 9. That minus 9 opposite operation is adding. We know that is the additive property of equality or addition property of equality. We add 9 to both sides. That's going to leave us with negative 4x is negative 4x is less than or equal to 16. We're then going to divide by, I'm trying to get this cursor game going on so it's not blocked. Divide by negative 4. We're trying to get rid of this negative 4 here. So we're going to divide by negative 4 on both sides, which is all well and good. But there is something that happens with an inequality that does not happen with an equation. Do you remember what that is? Okay, hopefully some of you are saying to yourselves, or maybe you said it out loud, that when I divide by a negative, I have to flip the sign. So we're going to make sure that when we do divide by negative 4, that negative 4 and this negative 4 are going to cancel and leave us with just x. And then our sign flips and becomes greater than or equal to negative 4. All right. Now, the other piece about an inequality, which is different from an equation, is you got to graph your solution. We're trying to say that anything that's greater than negative 4, greater than or equal to negative 4 would work if I plugged it into this solution. I'd get that this left side is less than 7. So I'm going to take, first we need a number line. We need numbers on our number line, right? So what I would essentially do is no matter how many numbers you had on your number line, I'm just going to put a few for time's sake. But I'm going to put my negative 4 right about in the middle, so to speak. Right? We know negative 4 goes there. We know negative 3 goes here. Negative 5 goes here. Negative 6 goes here, so on and so forth. Right? So then the question is, what kind of circle, and I guess you kind of have a hint right here, what kind of circle is going to go on my negative 4? Not negative 5, but negative 4. It's going to be closed. A closed circle, if you recall, means that it is including that point. So a closed circle there. If there were no equal sign here, then we wouldn't be including that point and it'd be an open circle. But it is a closed circle because we are including it. All right? So we're going to have to draw a line at this point, or shade. And our line for shading is going to be greater than, which is to the right. So to the right of this, I am going to draw my line here and put an arrow at the end to indicate that, it's a pretty big arrow, but to indicate that it is greater than or equal to negative 4. All right, cool, good. Let's move this out the way because we kind of determined that we weren't doing that, but we were putting everything on there. All right, so Jeremy wants to buy a new phone and he hears that it will cost at least, this keyword at least, does that mean he can save more than $800? Can he save more if he needs at least $800? Hopefully you said to yourself, yes. Can he save $800? Sure, absolutely he could. He could definitely save $800 and still hit the at least $800, but he could not save less than that. So we need to have $800 or more. So the symbol that we use here, you see right there, is is the greater than or equal to. And I know it has to be greater than or equal to my $800. All right. So that means everything that I'm saving needs to be greater than that. Well, what does it tell us? It tells us that he currently has $425 already saved. If you remember from what we've been doing recently, anytime I already have something at the beginning, before any time has passed, that's our starting value or our initial value. So that's going to be $425. And then I'm going to add $20 per each driveway. So every single driveway that I shovel, or Jeremy in this case shovels, he gets $20. So 20 times X. All right. So then our next step is to solve this. We're going to subtract 425 on both sides. When we do that, we're going to be left with, and I'll just move this here, 20x is greater than or equal to 375. When we go to solve that, we see here that we have to divide by 20 on both sides. This is my division bar on both sides. I'm going to end up getting 18.75. So I get x is greater than, not equal, but greater than or equal to 18.75. But I cannot shovel 18.75 driveways. You're not going to go to your neighbor and be like, hey, give me $20 to shovel 75% of your driveway. It's not going to happen, especially if you're charging $20 for a full driveway. They want to get out, right? So I have to round this up. The reason why I have to round it up is because it has to be greater than or equal to 18.75. So I'm going to round it up. Not because necessarily this is a 7, but more so because it's greater than. So I got to round it up, 19 driveways. All right, so Jeremy's got to shovel at least 19 driveways in order to get this $800, right? But they want to know what's a viable solution. So you're saying to yourself, well, anything that's greater than 19 driveways, right? But then it asks for you to justify your reasoning. So to justify your reasoning, this is what we're going to use. We're going to say, one viable solution would be for Jeremy to shovel 19 driveways. You could have picked anything 19 and above. All right, that's our viable solution statement. The next thing we're going to say is that if he shovels 19 driveways, he's going to make $805, which is obviously more, $5 more than the amount that he needs to buy the iPhone, right? So it's greater than the amount. The last thing I'm going to do, this reasoning, I'm going to show my work. So I'm going to try and make this disappear as much as I can. Put it up here. So here's my work. I plug in 19. Guess what? When I plug in 19, I see that this is 20 times 19 is 380, and I add it to the 425 I've already got, and I got $805. All right? So that's our activator. Let's look at what we're going to be doing today, and let's look at what you need. Something different than what you need, than what you typically would need is you're going to need a ruler and a calculator. So I'm going to give you about 30 seconds to make sure that you have those items. About 10 more seconds. All right, I know some of you are still grabbing your calculators and your rulers and maybe passing them out, which is perfectly fine. What I want to look at now is what the objective is for today. What we're going to be doing today is solving and graphing linear inequalities on a coordinate plane. So that's the key word here. Because before we were just graphing them on a number line. Now we're going to actually graph them on a grid, like an X, Y grid. Your homework tonight is going to be page 4 of this new packet that you were given, not any other packet. And you see here that I wrote exit card soon because you know that we typically have an exit card like every 2 to 3 days. So expect that it's probably going to be coming on Monday of next week. All right. So let's take a look at page 2. So everyone turn to page 2. You should have your calculator, your ruler, and your pencil. All right. So when we're graphing inequalities on a coordinate grid, it's really similar to graphing regular equations. Remember, we were just graphing regular equations. We needed to know the y-intercept. Notice I'm underlining that, intercept. And we needed to know the slope. So something that I might note for myself is that I need an m and I need a b. This m is my slope. I'm going to write it there, right under the m. And the b is my y-intercept. This is nothing new, but the purpose of you writing it again is to make sure you truly understand it for today's lesson. So I need an m and I need a b. All right. So here are some basics. Before we get to graphing anything, here's some basics. Here's some things we got to know. All right. Here's this inequality symbol. If you don't remember what this inequality symbol is, I would write, this is the greater than symbol. So in case you forgot, that's the greater than, just greater than. All right. Below that is less than. Below that is greater than or equal to. And then below that is less than or equal to. All right, really quickly. All right. If I'm graphing something that's just greater, and it doesn't have that equal symbol, I'm going to use what we call, or you can choose which one you like best, either a broken, dashed, or dotted line. They're all the same thing, but whatever word you recognize it as, you can use. I'm going to use a broken line. Make sure you're writing this in. That broken line indicates that it is not equal to. It's just greater than. All right? And then because it's greater than on a coordinate plane, when I go to shade it, my shading is going to go above. So in the shading column, you're going to write that it's above. And this is all going to make sense in a moment when we actually do it. All right, if I have less than, again, there's no equal sign here, just less than. Again, it's going to be the same type of line. Same type of line we had before. Broken, dashed, or dotted. It's going to be broken because it's not equal to. And then for my shading, because it's less than, which direction do you think we're going to shade? If you're thinking below, you're correct. It's below. All right. So then we have the greater than or equal to sign. You're probably thinking if it can't be broken or dashed because it has this equal to, it has to be solid. It should be a solid line. And because this is greater than or equal to, we're also shading above. And here this is less than or equal to. Less than or equal to is also going to be solid because of the fact that it's equal as well. But because it's less than, we're going to be shading below. All right. All right. Next on page 2, we're going to actually get right into it. Now, here's this remember tip at the top. Let's just disregard this tip at the top where it says, remember that if you have, it's not at the top, but I guess in the middle of your page 2. Don't worry about that just quite yet. All right. All right. So watch along and do with me as I do number 1. Okay. So do we have a y-intercept? Notice I'm always starting with the y-intercept. Yes, we do. It's -3. So I'm going to put a point at -3 on the y-intercept. So you should do the same. Do I have a slope? Yes, Miss Colo, you do have a slope. All right, your slope says 2, but I need it as a fraction. So as a fraction, what is your slope? It's 2/1, right? This here is 2/1. So what that means is I'm going to go to my original point, my y-intercept, and I'm going to go up 2/1, plot a point. I'm going to do it again. I'm going to go from that point up 2/1. And I'm going to, the standard is at least 3 points. I'm going to graph 4 since this is our first day doing it so that you can see it. All right, now here's where the new business comes in. Do I either have a broken line or a solid line, and do I shade above or below? So when I'm looking at this symbol, it says less than or equal to. So that means the line that I'm going to be drawing here is going to be a solid line. So you're going to take your straight edge, and you're just going to draw a solid line through those points. Notice that my graph goes all the way across the entire coordinate grid. That's not because I'm extra. That's because it has to be done, and I'm going to show you why in a second. So make sure your line goes all the way across. All right. Now on to the shading. Am I going to shade above or below? This is less than, and if I go back to the previous page, I see that less than, no matter what it is, whether it's less than or equal to, my shading is below. So I need to shade below. So I'm going to take, you're going to just take the side of your pencil or kind of etch it in, kind of shade it lightly. I'm going to use my highlighter tool here, and I'm going to shade below. Let me show you what below looks like. Here's my y-intercept here. It's going to be the side that's below. So it's going to be this side here. That's my below side. You might be looking at it as like, that's the right side. Well, when we're talking about a line that has that steep of a slope, this is the below side, and I'll show you a little bit more in a second. All right, let's look at the next one. Oh, wait, we didn't finish that. So here it says circle one of the solutions that's going to work. So anything that falls, how can I forget this? This is so important. Anything that falls in this shaded area, what happened to the cursor there? Anything that falls into the shaded area is going to be a solution. So when I'm looking at this, 0, 0, does that fall in the shaded area? No, it does not. So it's not a solution. All right, let's look at 3, 1. 1, 2, 3, and then I go up 1. That's right in that yellow area. So 3, 1 is definitely a solution. I'm going to circle it. All right, and let's look at -1, 5. I go over to -1, and then I would have to go up 5. That's absolutely not in the shaded area. All right, let's do number 2 together. All right, what's my y-intercept for number 2? And be careful. Your y-intercept is the constant, which is 3. So I'm going to put my y-intercept at 3, which is here on the y-axis. And do I have a slope here? Absolutely, of course. It is 1/2, and it's perfect because it's already written as a fraction. So that means I go up 1 and over 2 for my y-intercept. From that new point, again, I go up 1 over 2, up 1 over 2. All right, I got 4 points. Now here's the question. Is it a solid line or is it a broken line? Well, when I look at this, I see that it's not underlined, it's not equal to, so it has to be a broken line. So now we're going to graph a broken line. So how do you do that? It's up to you. I have had some students in the past draw a line and then just erase. I don't think, just pick up your pencil and just like do it just draw a line, but just mark it every other like step so that it's just a broken line. Still with your ruler. All right. Now the last part is the shading. So the shading says above. If you notice, this line isn't as steep as the first one was, and so it's easy to see what's above and what's below. So here's the above side here. This is above. There you go. So it's a broken line. Now let me explain what this broken line means in this case. So anything, let's look at number 1. Anything that fell on that solid line would be included. So if they said, hey, is 1, -1, this point here, a solution? Yeah, absolutely. They said, hey, is 3, 3 a solution? I say, sure, absolutely it is. But when I go to a broken line, anything that falls on a broken line is not a solution. So let's see what they give us. Here they have 0, 3. That's on the line, but it's a broken line, so not a solution. They try and get you like that, all right? Then I'll look at 6, 5. 6, 5 is not in the shaded area. But when I go to -2, so I go over -2 and I go up 1, 2, 3, 4, that is right in that yellow area. And so there we have it. All right. So I'm going to ask now that the sub or someone pauses this for just about, I don't know, let's say a few minutes. And you all do numbers 3 and number 6. So what I'm going to ask is you do number 3, go on and do number 3 and number 6. And number 3 and number 6 on the same page. Let's give us about, I don't know, about 5 minutes to get it done if that's needed. But once everyone's done, you can move on. So let's just pause this for about a few minutes. All right, so what you see here is the solution to number 3. Your graph should have a y-intercept of -1, and it should have gone up 3 and over 1. Remember, when your slope is a whole number, you have to make sure you convert it into a fraction whole number, and a fraction is just over 1. So up 3 over 1, it's a broken line, and the shaded is below. All right. And then next, number 6. Check number 6. Now, with this problem, you got to be careful because you're saying to yourself, well, what's the y-intercept? Don't get confused and say 1. When there is no y-intercept, I'm trying to figure out what is it saying. What's my plus b? What's my mx plus b? If I were to add a number here, it would be 0. So your y-intercept should be 0. You go up 4 over 1. I got the third point on here by going back to origin and down 4 over 1. And I got my 3 points. Okay? So 1, 1 is the only thing that falls into that shaded area. All right. Really quickly, the only other thing that I wanted to make sure that you knew before we go on to the next thing is, what does it truly mean to shade above or below, right? So sometimes you get these really, really steep lines, right, that look like kind of like this. They're really, really steep. And so, and when I say steep, they're very close to vertical, right? And so you're trying to figure out, Ms. Cola, what's above and what's below? All right, so if I'm trying to figure out what's above and what's below, I'm going to try and find my y-intercept for a line like this. This is my y-intercept. If I was shading below this y-intercept, I would be shading on below my y-intercept. So if I was shading below on this graph, because I was given a less than symbol, I would be shading on this side because this is the side that's below my y-intercept, right? So I'd be shading, oh, you see that went a little off, but I'd be shading this side. All right. Now, if it said greater than this, I'm looking at my y-intercept again, and I'm going to go above my y-intercept. So it would be the side that's above, and I would shade. Oh, I'm on my laptop, so that's why this looks so bad. But I would be shading that side, okay? All right, let's look at another one really quickly and then I'll move on. Let's say we had a line that looked like this. Still very steep, right? And you're saying, what's above this line? Well, what if someone told me that this was greater than or equal to, I would go to my y-intercept and see what's above, because it's greater than or equal to. This is the side that's above, so that's the side that I'm going to shade. So it would be like this. It would look way better, but I'm on my MacBook, and yeah, so it's kind of hard. All right, so that will be above, and the opposite side would be below. All right, so here's number 6 again, just in case if you missed it. All right, let's look at the next part. Manipulating the inequality. All right, so it says, sometimes the equation will not already be in slope-intercept form. Look at it. What is slope-intercept form, everyone? Y equals mx plus b. So right above where it says slope-intercept, where I want you to write y equals mx plus b, because that's the form we need all of these equations to be in so that we can graph them, because we need those two things. We need the slope and we need the y-intercept. So we need the slope and we need the y-intercept. Not in that order, right? We need the y-intercept first because that's where we start, and then we need the slope. All right. So let's take a look at how this is done. I'm going to pause this for just 1 second. All right, so I had to cover up my answers and whatnot because I didn't have it up the way that it should have been. All right, so listen up. So hopefully you can see everything on the screen and everything looks good. Okay, so I have to get this into y equals mx plus b, and that's what you had written here, y equals mx plus b. So in order to do that, it's kind of like a literal equation. Remember when we were given an equation that had a lot of variables in it, and then you just had to solve for one? Well, in this case, our goal is to solve for y. Why do we solve for y? Because we need to get it in slope-intercept form. And in that form, y is by itself. See? Look at that. Y is by itself. All right. So we need to get this y by itself. So our very first step in number 7, if you want to follow along with me, is going to be to get this 2y by itself. So then we can get y by itself. So to get this 2y by itself, we need to get rid of plus 2x. So we subtract 2x from both sides. So go ahead and write that. What are you left with when you do that? Notice how I write it. I write it this way. 2y is going to be it's going to be less than or equal to negative 2x plus 6. Notice I put the negative 2x first. Ms. Colo, do I have to put the negative 2x first? Could I put 6 minus 2x? Absolutely, you could. But again, I keep this in slope-intercept form. All right? So our last step is to divide by negative 2. Divide by positive 2. It's late. Divide by positive 2. When I do that, I'm going to be left with y is less than or equal to negative 1x plus 3. So then what I do is I go to my positive 3. And then here my slope is negative 1 over 1. So I go down 1 over 1, down 1 over 1. And I keep doing that just for, again, I like to do it 3 times, or 4 times rather. And this is a solid line. And so here's my solid line here, that way. And it's less than, so I'm going to be shading below my solid line, which is like this. So anything that falls in this solution is viable. And this area, is viable. Let's look at the next one. And then I'll let you do number 9 and any other ones that you can do on your own. All right. So here I have 1/2 x minus y is greater than 4. So again, we've got to get this y by itself. Notice that this minus sign is here in front of it too. So that's going to come into play. All right. So first I got to get rid of this 1/2 x. It's positive, so I subtract 1/2 x on both sides. So go ahead and do that. I realize some of you might be shading, so I'll give you another second just in case you're catching up. All right, after we subtract 1/2 x on both sides, I'm going to be left with, don't forget that negative. I'm going to be left with negative y is just greater than, there we go, is just greater than negative 1/2 x plus 4. All right, we're very close to getting the y by itself, but we're not done. So what we have to do is divide by something to get rid of that negative sign. Remember, anything times 1 is itself. So if I just have this negative y, it's the same thing as negative 1y. So I'm going to divide by negative 1 on both sides. But here comes another inequality rule. So you see why these are not hard. You just have to remember all of the things that are important about solving it, making sure that you're accurate. So we got to flip the sign here. So we flip the sign, and now our answer is positive y is less than 1/2 x. And then remember, 4 divided by negative 1 becomes negative, and this negative 1/2 divided by negative 1 becomes positive. So that's why we have this positive 1/2 x minus 4. All right, so what I'm going to do is my y-intercept here is negative 4. So 1, 2, 3, 4. I put my negative 4 is my y-intercept. My slope is already as a fraction, so it's up 1 over 2, rise over run. And I'm just going to duplicate this. Up 1 over 2. Up 1 over 2. I got 4 points. Now, here's the deal. It's just less than. That means it's going to be a broken line this time. So it's going to be a broken line. That wasn't a very well-drawn line. So let me make sure it's straight. And my shading goes below this line. So it's just this little corner here. All right? So in this case, anything that falls on this line is not a solution, but anything that's in the yellow area is. All right? I'm going to ask the sub to pause this for a little bit. I'm going to ask that you do numbers 9, 10, 11, and 12 if you get to it. And I will show you the answer to, I believe, let's see. I'll show you the answer to all of them. So I'm going to ask the sub to pause it and to resume based on whatever time you have left in class. That gives enough for you to check the next few problems if you do it. So please pause now. All right, let's take a look at number 9. So for number 9, you should have gotten y is greater than or equal to negative 2 plus 8. If you notice that this time, the 8 as our y-intercept isn't on the graph. So you might have been confused, and rightfully so. I definitely understand. It's not on the graph. But I'm going to kind of pretend where it might be. And the slope is negative 2 over 1. So that means I would go down 2 and over 1, which would be to this 1 comma 6 here. And I would continue to do that. Some of you might not have graphed it because that point isn't there. But our expectation is that you can still graph other points. So graph as many points as you possibly can. All right, and then this is greater than or equal to. So this is definitely going to be another solid line because it's equal to as well. It's going to be a solid line. Again, my points are a little funky because of that. All right, and then my shading is going to go above. So it's going to be here because it's greater than. All right, let's look at numbers 10, 11, and 12. Take a look at the answers that I've gotten here. I subtracted by 8x on both sides, and I divided by a negative 6. When I divide by negative 6 on both sides, the sign flips. I simplified negative 8 divided by negative 6, and that's 4/3 x minus 2. If I graph that, my y-intercept is negative 2. I go up 4 over 3. If I go up 4, 1, 2, 3, 4 over 3, 1, 2, 3. I'm just going to graph those for time's sake. But typically, again, we would graph 3 to 4 points. It's a solid line because it's equal to. And I'll fix this. It's going to be greater than, which is above. So it looks like this. All of this should be shaded. Now, if I had better time, I'd shade much better. Let's look at number 11. I subtract by 5x on both sides, divide by 10. Again, simplify negative 5 over 10 to negative 1/2. Here's another problem where my y-intercept is 0. There's no plus anything, so it's at 0. All right, this time it's just greater than, so it's a broken line. and it goes up 1 over 2, up over 2, up 1, oops, up 1, no, I'm all wrong. It's down 1 over 2, down 1 over 2, and I could go the opposite way, 1 over 2, up 1 over 2. So it's going to look something like that. And then your graphing is going to be above the line. And for the last graph, I didn't really put the points. I'll do it for the last one. Your y-intercept is positive 3. And your slope here is negative 2 over 1. So I'm going down 2 over 1, down 2 over 1, down 2 over 1. And this is a broken line because there is no equal to symbol here. So I'm going to down 2 over 1, down 2 over 1. It just looks crooked, and I don't like it, but it's fine. All right, I'm going to make sure it goes all the way across. Again, this is greater than, just like our last problem. And so I'm shading above, which is going to look like this. All right. So your homework is page 4 tonight. You have everything that you need. Remember, if it's not in y-intercept form, like these last problems that we did, numbers 7 through 12, then make sure you do put it in slope-intercept form. All right? Come see me in E207 if you have any questions. Have a great day. Bye-bye.